Hi everyone. Today we are solving an interesting LeetCode problem. It's a lexicographically smallest string after applying the operation. So here you can see it's a medium level problem that will test your understanding of string manipulation and the breadth first search. So first let's go through the problem statement. Here we are given an string s of even length made up of digit from 0 to 9 and then two integer a and b. So just I will write the problem in a simple form. Here we are given an string of even length, okay, even length made up of digits from 0 to 9, okay, and here we are also given an two integer a and b, two integer a and b, okay, and here we can perform the two operation any number of time in any order, and we can perform the two operation any number of times in any order. Like what are those two operations? First one is the add operation and the second one is the here you can see it's a rotate operation, okay. So coming first to the add operation, in this add operation, so like in this add operation, like we will add the a to the all digits to only like odd indices, and if a digit exceeds the 9 it's wrap around to the 0. Like in this add operation, add a to all digit only at odd indices, okay, only at odd indices, and like if a digit exceeds the 9, it's the wraps around to 0, okay. So let me give you one simple example. In this example, consider a string s whose value is 3 4 5 6, okay. So and a equal to 5, okay. Then this will become like after adding the a to the odd indexes, it will become like 3 uh 5 9 5 and 1, okay. Yeah, so this was all add operation, and the second operation we can perform is rotate operation. rotate operation like in this rotate operation, we will rotate the string s to the right by 0 position. Like in we will rotate string s to right, okay. We will rotate string s to right by this b position, okay. Let me give you one simple example here. Here we can consider a string of values like 3 4 5 6, okay, and here b is 1, okay. Then after rotating it will become, after rotating it becomes string by right position, so it will become 6 3 4 5, okay. So these are the two operations we can perform any number of time in any order, okay. And from here our goal is to find the lexicographically smallest string possible after applying this operation any number of time. So here you can see one example. I will explain this example only. So in this example, uh, like consider an string s whose values to be 5525 5525, and here it's a is 9 and b is 2. Okay, b is 2. Okay, like here what are the operations we can perform? Like we can perform, first we can like this, add 9 to add 9 to odd indices, then it will become like 5024 2, yeah, 4, and then we can rotate it right by 2, rotate it right by 2, then it becomes like 2450. Okay, then it becomes 2450. Okay, after, and like we can like again add 9 again, then it will become 2050. Okay, so we can perform this type of operation any number of time in any order. So from here, like the smallest string we can get is like 2050, so we will return this. Okay, coming to the like approach how we will solve this problem. Like now how do we find this smallest string efficiently? Like here we can think of the, like, one second, like, yeah, uh here we can think of uh, each operation, like basically here you can think of the each operation as moving from one string state to the another. Like since we can apply the operation infinitely, we need to explore all the possible states but without the repetition. Like basically it's a graph traversal problem where you can treat the each node is string and the each edges is one operation like add or rotate, and we will use the BFS, breadth first search, to explore all the possible transformation. So, how we will use the BFS efficiently here? Like here, we will start from the original string and apply the both operation to generate the new string, and then we will use a set to avoid the revisiting the same string, and we will keep the track of the smallest string we found. And since the number of the unique state is limited because of the finite digits and the rotation, BFS will terminate efficiently. So let me give you the approach here for this problem. Here approach is that you can think of each operation as moving from string one state from the another. Since we can apply like operation like, so this is a graph traversal problem, like where each node is string. Okay, where each node is string and each is where each node is string and like each edge is one operation, each edge is one operation, whether it be add or rotate. Okay, add or rotate. So here we will use the BFS to explore all possible transformation as explained earlier. So use BFS to explore all all possible transformations. Okay, so I will also give the steps to use the to apply the BFS here. Here we will first start from the original string. Start from the original string. Okay. In the second step, we will apply both operation to generate a new string. So apply both operation to generate new string. Okay. And here we will make use of one set. Use a set. Why? We will use a set to avoid the revisiting the same string. Use the set to avoid revisiting the same string. Okay. Okay, and then at last step we will keep track of the smallest string found. So keep track of the smallest string found. Okay, so these are the simple 4 steps. If we apply them efficiently, I think we will get our solution. So let me first comment out this part. Yeah, now let's come to the code part. Yeah, I have commented all the parts here efficiently. Yeah. Coming to the code part. Yeah, from here. Like first of all, we will make use of one queue. Okay. Why this queue? Like the queue for the BFS traversal to explore all the possible string state. So queue equal to new linked list. So this is a way of declaring queue in the Java. And then we will make use of one like set. Why? To set to keep the track of the visited string to avoid processing the same string again and again. So we'll make use of one set string visited equal to new has set. Okay, and then here we will like initialize the smallest like here we will now initialize the smallest string as the original input string. Okay, so string smallest equal to s, like this is our original input string, no? Now then after that we will add the initial string to the queue and make it as visited. Queue dot offer s and make it visited dot add of s. Okay, now from here, oh sorry, now from here we will perform the BFS until all reachable state are processed. Like I will comment out this part. From here we will perform the BFS. Why? Until all reachable like until all reachable states are processed. Okay, so so while q dot is, so here I am applying the BFS. mm, while q is not empty, in this take one string from the queue, like string q dot pull. We we took one string from the queue, and then compare this current string with the smallest found so far. Now we will compare this current with the smallest found so far, and if the current string is lexicographically smaller, we will update the smallest. So if this current compare to smallest 0, here what we'll do, we will update the smallest. Okay, here we update the smallest. Now coming to the first operation, what was our first operation? Add a to the all digit at odd indices. So char chars to current dot to char array. Okay, here we are converting the string to the character array for modification. This line, but converting the string to the character array for modification. Okay, now here we will traverse only the odd indices like 1, 3, 5 and so on. So for that we will make use of one for loop. For int I equal to 1, I less than chars dot length, and I plus 2, we will move 2 to now then we will convert the character to the integer digit and add a and wrap around using the modulo 10. So int digit char of I is 0 plus a modulo 10. Like what we did in this step, we converted the character to the integer digit and added a and wrap around using the modulo 10. Okay, and in this step we will convert back to the character and update in the array. So chars of I char of digit 0. Okay, like converted back to the character and updated in an array. Okay, and in this step like we will convert the modified character array back to the string. So string added equal to new string chars. Okay. Now in the operation 2, now we will perform our operation 2. So what was our operation 2? Our operation 2 was to rotate the string to the right by b. Okay. So this is the code for an operation 2. Rotated equal to current dot sub string current dot length minus b. Okay. Plus current dot sub string current dot substring sub string 0 current dot g length minus b. Okay. Minus b. Now here like we will add a new state to the BFS queue if they haven't been visited, and if added string is new, add it to the queue and mark it the visited. Like here if the visited dot added, then queue dot added. Okay. Now what we will check here, we will check that if the rotated string is new, add it to the queue and mark it as visited. If visited dot add of rotated, then queue dot for of rotated. Okay. Now from here like let me see, this is the end of the while loop. Okay. Now in this last step, like after exploring all the possible transformation, we will return the smallest string found. So from here, from here return the smallest. Okay. Now let's submit and see whether it's passing the given test cases or not. Compile. What is the problem here? Let me see. This is dot char of I expected for int I. Let me see character current minus 0. Yeah, perform the BFS, no? So while it is not while string if character for int traverse only int digit equal to int digit equal to chars. Yeah, chars of I 0 plus a modulo 10. It was chars, not char. If current dot compare to now where what is this? If current dot compare, okay, this two. They are the silly mistake, like a typo mistake. Yeah, string rotated equal to current dot substring current dot length minus b, okay, plus current dot substring 0 to current dot length minus b. So what is the problem? I think q dot offer cannot find the simple current dot length. One second. length okay, length string dot current le. Oh, it was length. Oh yeah, it will be q dot offer. Yeah, here we have passed all the given test cases. Now let's submit and see whether it's passing all the hidden test cases or not. Yeah, we have also passed all the hidden test cases here. So basically, this algorithms uses this algorithms uses breadth firsters BFS to explore all the possible string generated by repeatedly applying the two operation, add operation and that rotate operation. And here this a set ensures we don't revisit the same string, preventing the infinite loop, and then we keep updating the smallest string whenever we find a lexicographically a smaller one. So the process continues until all reachable states are explored. So this was the problem, like it was the medium level problem.